Okay, if you'll give me your attention, please. The effects you just saw through the spectral viewers are the result of the way electrons are arranged in the electron cloud. Every electron, or every pair of electrons, if you've got two electrons in an orbital, have a slightly different behavior. And that's where we get all those different colors from. Now, all the orbital notations and electron configurations and things like that we do in here are for what are called the ground state electrons. That is, electrons that have not been excited by electricity, as you saw, or like flames we used the other day. So, we're not going to be looking at the way that electrons are arranged in those excited states, but that's how you get that sort of thing. What happens is they get in the excited state and they give off the colors when they drop back down to a lower state, either to the ground state or something between the two. What we want to do, though, is take a look now at how electrons are actually arranged. So far with orbital notation, and we're going to get the electron configuration later, we've been sort of arranging electrons in a kind of, I don't know, what I call it, an inventory sort of system, okay? What I want to do now is take a look at how electrons actually, where they actually live within the electron cloud of an atom. Now, when you were doing physical science, you remember, and we've done this already in this unit, I think, we arranged electrons in sphericals, circles which represented spheres, right? Okay? So in the first primary energy level, there was a sphere, and we said there were two electrons in there. And that's pretty true. The first primary energy level has a sublevel. We looked at that in when we did orbital notation. That's called S. So there's the first sublevel you come to is 1s. Okay, there is an S sublevel, and the S sublevel only has one orbital. Well, that S orbital is always spherical. So that first primary energy level is an S sublevel. I mean, that's just what it is. Okay? Things start to get a bit more complex when we get to that second primary energy level, however, because in that second primary energy level, not only do we have an S orbital, which is still that same spherical shape, but within that spherical shape, we've got the p orbitals, and there are three of those. Remember that electrons have a negative charge, and we allow two electrons, or we think about electrons being able to get into the same region, is having opposite spins in order to cancel out their electromagnetic repulsion. But those pairs of electrons then have to be as far apart as possible because, you know, they have the same charge. They need to push apart. And so what happens is electrons arrange themselves in regions within this primary energy level. And so you've got these p orbitals which look like two mushroom heads sitting in here. Okay? So this makes up one p orbital. These two parts make up a p orbital. Okay? And then I've got another p orbital at 90 degrees to that, where I have two parts of the same p orbital. Okay? Two mushroom heads sort of floating in space out there. Well, there's a third p orbital, but I can't fit it in a two-dimensional drawing like this. I need 3 dimensions, and that's where the difficulty becomes in relating something that's 3-dimensional in some 2-dimensional drawing. It's kind of hard to do. That third orbital is going to be here above the paper, sitting out here, and then back below the paper down here. So in 3 dimensions, I can't really draw that very well. I could show it to you, but it becomes kind of complex and, you know, sort of complicated in terms of how you draw it and what it's supposed to look like, so it's hard to tell what's going on. So you've got to use your imagination a little bit, because there isn't any really good way to show it, but we're going to show it a little bit. Okay? So instead of using orbitals that look like two mushroom heads, because I've got no way to make models like that. Okay? In our world, in our existence, many, many, many thousands of times bigger than that, we don't have anything that behaves that way. So instead of doing mushroom heads that float out in space like that, we're going to take a p orbital, which is kind of a mushroom head. Sounds like the name of a band, doesn't it? Mushroom heads. Okay? We're going to take and use, and there's the nucleus, and we're going to use our round balloons to make something that looks like that. Okay? So we'll be tying a round balloon and knotting it. tying around, blowing up a second balloon the same size and knotting it and then tying them together. And that'll make a p orbital. Okay, and that's the way a lot of times you see them represented, even in textbooks. Okay? And there's got to be 3 of them. So we'll have one set of these balloons. That's where you have to have 2 balloons of the same color. So the 2 nodes, these are called nodes of the same orbital. The 2 nodes of the same orbital here have to be the same color in your balloon scheme. And then you have a different set of colors for this second orbital. Okay? And then you have a third set of balloons with a different color for that last orbital that's kind of coming out in front and is kind of back here in the back somewhere. Okay? Does that make sense what we're doing? All right? Now the thing to remember is it's only the top half of the balloon that's actually part of the orbital. The bottom half is kind of like it's there because we've got to have it, but it doesn't really exist. So when you do this, you need to draw a dotted line around the center of every one of these balloons. Okay, so that we can label where our orbitals are. Now these are just the p orbitals. We're not doing s orbitals today, just the p orbitals. Okay? Now then, I want to remind you about something you already know. You know what that's called? Yeah, like you make it a graph. It's called the Cartesian Plane. Okay? Well, that has 2 dimensions in it. How would we represent 3 dimensions? A z-axis. So you have one coming out toward you, like this. Okay? And then it's going back behind like that, right? So that's x, y, and z. Well, if we have these balloons on x, y, and z here, we could call this p orbital on, you want to call that y? Okay, that'd be p sub y. P sub y. Okay, but remember it's only the top half. So this is also p sub y down here. Does that make sense? And this balloon we're going to put on this axis here. What's that going to be called? P, we could call it p sub x. Remember, it's only the top half though, so this is p sub x here. P sub x here. Okay. And then I've got to have a balloon sitting on this axis here. It's kind of like sitting around it here, sort of, kind of, sort of. Okay. The top half. And that's p sub z. Wow, this is getting complex already, isn't it? So this is why we need the models to kind of visualize some things. Some people are really good at seeing this sort of stuff in 3 dimensions, and some people aren't. Okay? So for those of you who can see this stuff in your brain, you're ahead of the game, great. But then you can help out people who don't quite get it, okay? So, you ready to start blowing up balloons now? Alright, so get out 2 balloons of the same color, blow them up the same size, and knot them off.
How big?
Doesn't matter how big, but I wouldn't blow them up as big as you can get them because then it makes it harder to tie. Well, you decide. Okay? All your balloons are going to be the same size, okay?